Okay, so this video is a review of the concept of a mole, and specifically what I want to address is the issue of true understanding. So if we look at this question that I have written on the screen, which quantity has more particles, 24 grams of carbon or 23 grams of sodium? Many individuals are going to look at that and they're going to evaluate the answer based on comparing the masses of the two particles, and they're going to look at the carbon and go, well, there's 24 grams of carbon, so there must be more of it. But this signals a lack of understanding regarding the mole concept. So the thing is, here's what you need to remember. All right, the mole is a grouping. The mole is a grouping. Okay, just like the dozen. All right, the concept dozen is also a grouping. And what I mean by that is that in the case of the mole, there are 6.022 times 10 to the 23rd particles. That's what I mean by grouping. So we have decided to use this name to distinguish a number, and that number is 6.022 times 10 to the 23rd. Just like with the dozen, all right, we utilize this name to indicate that there are 12 of whatever. All right, I'm just going to say it's 12 particles, but it could be 12 of anything. Particles, cars, apples, oranges, and on and on and on. All right, and literally though, we can apply the mole the same exact way if we want to. So we're saying that it's 6.022 times 10 to the 23rd particles, and in chemistry we apply this to atoms, molecules, formula units of ionic compounds, and so on. But literally you could apply this grouping to anything in a literal sense. We could say that we've got 1 mole of apples, or 1 mole of oranges, or 1 mole of people. The mole grouping is a really huge number, but it has to be, because when you look at atoms and molecules and so on, these are very small particles, and very small amounts of them have huge numbers of particles in them. So we utilize a grouping that has a big number, because when we divide a certain amount of a set of atoms or molecules by this number, we need to get a ratio from that, or we need to get a number out of that that is a reasonable number on human terms, something that's somewhere close to a reasonable decimal or whole number, something along that fashion. If we were using the concept dozen, this grouping is not big enough, and dividing a really huge number by 12 isn't going to do us much good. Now, in the case of the grouping, this alone is not enough to provide us a method for counting atoms and molecules without actually having to count them. And when we're considering numbers like that are represented here, like 24 grams of carbon or 23 grams of sodium, the literal numbers of atoms that are in 24 grams of carbon and or in 23 grams of sodium is a huge number. It's not the kind of thing that we could count. So in terms of chemistry, what's been done is we've combined the concept of the grouping with mass. All right, and the reason that we do that is because in terms of mass, we can use a scale literally to mass atoms and molecules, various different types of compounds, and so on, we can mass that material out in the laboratory. Just like you can stand on a bathroom scale and get your weight, we can take materials in the laboratory, put them on a scale, and we can get a mass. The way this works is, and I'm just going to generalize this, is if we look at the periodic table, and we're going to look at carbon in this case and sodium, since that's the nature of the problem before us. If we look on the periodic table, we see in the corresponding boxes for these two elements the atomic masses, which are written below the symbol. These masses represent what we call molar mass. And molar mass has the units of grams per mole. That's mass per grouping. Mass per grouping. So when we look at sodium, we see that literally, if we mass out 22.99 grams of sodium on a scale, that mass has 6.022 times 10 to the 23rd atoms in it. So if we were to mass this out, all right, on the scale, and fill it up with, we fill up this weigh boat or this little dish with sodium to the point where the scale reads 22.99 grams, then we have exactly 1 mole, 1 grouping of this atom in here, which means that we have 6.022 times 10 to the 23rd particles in the weigh boat. So we can use mass to count. So coming back to the problem, what the problem is asking is, it wants to know which of these two masses has more particles in it. So you compare 24 grams of carbon with 23 grams of sodium. Look at the periodic table. We see that sodium's molar mass is 22.99 grams, which is just about 23. That means that this mass is approximately 1 mole. 6 times 10 to the 23rd. 6.022 times 10 to the 23rd atoms. When we look at the carbon, 24 grams. This is approximately a doubling of its molar mass. So this is about 2 moles. It's approximately 2 moles. Okay, that's 2 times 6.022 times 10 to the 23rd atoms. All right? So this mass amount of carbon right here has twice as many particles as the sodium. Twice the number as Na. Because there's, based on the problem, see, we were given 24 grams of carbon, which is literally double this number. So there's twice the number of carbon, twice the number of carbon as sodium, right? That's the answer to the question. More importantly is whether or not you understand molar mass so that you can apply it to problems like this.